Ever walked on a road and wondered, is this asphalt or tarmac? Most people think they're the same, but they're actually quite different. From how they're made to how they perform under traffic, asphalt and tarmac each have unique strengths and weaknesses. In this video, we'll break down the real differences between the two, covering their composition, uses, durability, cost, and more. Whether you're a civil engineering student or just curious, this video has the answers. Let's dive in. Hello, welcome back to Civil Engineering Edge. Opening hook, visual, side-by-side road surfaces, tarmac versus asphalt. Have you ever walked down a road and wondered, is this asphalt or tarmac under my feet? Both look similar, both are used for road construction, but are they really the same? Well, not quite. While people often use the terms tarmac and asphalt interchangeably, they are actually two different materials, each with its own composition, history, usage, and performance. In this video, we'll break down the real differences between asphalt and tarmac, how they're made, where they're used, what makes each unique, and when one is preferred over the other. Stick with us till the end, because this knowledge could change how you look at roads forever. Section 1. The common misconception. Yes, both tarmac and asphalt are used in road surfacing, but if you take a closer look, you'll notice subtle differences. Tarmac tends to have a rougher, more textured look, sometimes appearing slightly brighter or coarser than asphalt. On the other hand, asphalt often looks smoother, darker, and more uniform. But are these visual differences enough to determine how durable or strong a road will be? Let's dive deeper and understand how these two materials really compare. Section 2. What is asphalt? Asphalt is a petroleum-based material, often black or deep brown in color. It can range in consistency from a sticky liquid to a glassy, solid form. Chemically, it's composed mainly of hydrocarbons with small traces of sulfur, nitrogen, and oxygen. There are two primary sources of asphalt. 1. Natural deposits, found in regions like Trinidad or the Dead Sea. 2. Byproduct of petroleum refining, the more commonly used form in modern construction. Historically, asphalt dates back thousands of years. Ancient civilizations used it for waterproofing and even as mortar in construction. Archaeological findings from 3000 BCE in present-day Pakistan show asphalt used in brick reservoirs. The ancient Mesopotamians used it to seal canals and roads, a practice still essential today. Now, let's understand how modern asphalt is made. Asphalt is typically produced in hot mix plants, where it's formed by combining crushed aggregates like stone, sand, or gravel, bitumen, a sticky, black binder derived from crude oil. Here's how the process works. 1. Bitumen is heated to make it more fluid. 2. Aggregates are cleaned, dried, and heated to remove moisture. 3. The two are thoroughly mixed to create a uniform hot asphalt blend. 4. This mixture is then transported to construction sites, where it's spread, leveled, and compacted with heavy rollers. Once it cools, asphalt hardens into a durable, weather-resistant surface. It's widely used for highways and expressways, airport runways, parking lots, driveways, bicycle and pedestrian paths. One important thing to note, asphalt takes up to 2 days to fully cure, which means it remains workable longer during installation. This makes it ideal for large-scale projects that require seamless finishing. Transition to tarmac. Now that we've covered asphalt, let's shift gears and talk about tarmac, a road surfacing material that played a revolutionary role in the evolution of modern transportation. Section 3. The invention of tarmac. The early macadam roads designed by Scottish engineer John Loudon Macadam were an improvement over dirt tracks. They still had major issues. They produced clouds of dust and degraded quickly under the weight of increasing traffic and heavier vehicles. This led to a critical innovation. In 1901, Edgar Pernalilly took the concept of macadamized roads one step further by adding tar as a binding agent. This innovation gave birth to what we now call tarmac, short for tar macadam. By binding the crushed stone layers with tar, the roads became significantly more durable, dust-free, and weather-resistant. Section 4. How tarmac is made. Modern tarmac is produced by mixing clean, dry aggregates, usually crushed stone or gravel, with tar. The process starts by selecting high-quality aggregates that are washed, dried, and sorted to ensure uniformity. Meanwhile, coal tar or a similar tar-based binder is heated until it becomes fluid. Once the hot tar reaches the right viscosity, it's thoroughly mixed with the prepared aggregates to ensure every stone is coated evenly. This blend is then laid out on the road's surface, leveled and compacted using heavy rollers to achieve a flat, strong surface. As the tarmac cools and hardens, it forms a resilient and stable surface capable of handling weather fluctuations and regular traffic. The result is a smooth road that can support vehicles without quickly deteriorating. Section 5. Where is tarmac used today? While asphalt has largely replaced tarmac in modern infrastructure projects due to its better flexibility and longevity, tarmac still holds its ground, particularly in specific use cases. You'll still find tarmac being used in rural roads and village pathways, driveways and private lanes, sports courts and walkways, parking lots, and interestingly, airports. Although people often use the word tarmac for runways, many of them are actually made from asphalt or even concrete. So, despite its decreasing popularity in large-scale highway projects, tarmac remains a reliable surfacing solution in many sectors due to its cost-effectiveness and strength. Section 6. Tarmac versus asphalt. Key differences. Now that we've looked at how each material is made and used, let's talk about what really sets tarmac and asphalt apart. 1. Surface texture and appearance. One of the most noticeable differences lies in the finish of the two materials. Asphalt produces a smoother, darker, more polished surface. Tarmac, in contrast, has a coarser texture due to the larger aggregates and the nature of tar. This refined surface of asphalt not only looks more aesthetically pleasing, but also provides better traction for vehicles, especially in high-speed or high-traffic zones. It offers improved grip during wet or icy conditions, reducing the risk of skidding. That's why asphalt is the preferred choice for modern highways and expressways. 2. Flexibility and longevity. Asphalt is known for its flexibility, which allows it to expand and contract slightly with temperature changes. This characteristic reduces the chances of surface cracks or breakage over time. Tarmac, being less flexible, is more prone to cracking under stress, especially in areas with intense traffic or extreme weather. This is one reason why asphalt has become the go-to material in contemporary infrastructure. 3. Environmental impact and recyclability. Another major difference lies in their environmental impact. Asphalt is 100% recyclable. Old asphalt can be scraped, reheated, remixed, and reused in new construction projects, making it a sustainable and eco-friendly choice. Tarmac, however, is not recyclable in the same way. Once laid, it cannot be reprocessed easily, which makes its environmental footprint larger over the long term. 4. Application preferences. Asphalt is best suited for highways, city roads, commercial parking lots, and places with frequent heavy use. Tarmac finds its niche in driveways, rural paths, playgrounds, and surfaces that don't require daily heavy-duty wear and tear. So, while both tarmac and asphalt serve similar functions, creating durable road surfaces, they differ significantly in their composition, production, durability, surface finish, and eco-friendliness. To quickly recap, asphalt equals bitumen plus fine aggregates, smoother, flexible, and recyclable. Tarmac equals tar plus larger aggregates, coarser, stronger in static load conditions, but less recyclable. Each has its advantages and ideal applications, and knowing the difference helps in making informed decisions when it comes to road construction and maintenance. Section 7. Recyclability. Asphalt wins in sustainability. One of the biggest advantages of asphalt over tarmac lies in its recyclability. When old asphalt surfaces are removed during road repairs or resurfacing, the material doesn't go to waste. Instead, it's crushed, reheated, and mixed with new bitumen and aggregates to form reclaimed asphalt pavement wrap. This process drastically reduces construction waste and helps conserve valuable natural resources. This ability to reuse old asphalt makes it a sustainable and cost-effective choice, especially for governments and infrastructure developers aiming to reduce environmental impact and lower project costs. On the other hand, tarmac cannot be effectively recycled. Once it's laid, it's more or less permanent. The reason? Tar, which acts as the binding agent in tarmac, does not break down easily and can't be reheated and reused like bitumen. As a result, when a tarmac surface deteriorates or becomes damaged, it typically needs to be entirely removed and discarded. This generates more construction waste and contributes to a higher environmental footprint. Due to this limitation, tarmac is less commonly used in modern infrastructure, where eco-friendliness and sustainability are increasingly important. Section 8. Cost comparison. Short-term versus long-term value. When it comes to cost, the answer isn't as straightforward as you might think. Asphalt tends to be more expensive upfront than tarmac. This is due to the higher quality of materials involved, the need for specialized machinery, and longer installation times. For large-scale highways and heavy-use roads, the initial cost of asphalt can be significant. However, asphalt pays off in the long run. Thanks to its longer lifespan and lower maintenance requirements, it ends up being more cost-effective over time. On the other hand, tarmac is cheaper to install, especially in low-traffic or rural areas. It's quicker to lay down and requires less complex equipment, making it a popular choice for temporary roads, private driveways, or secondary lanes. But due to higher maintenance needs, it may cost more over its lifetime if frequently repaired or resurfaced. So, if you're looking at long-term investment, asphalt is generally the better option. Section 9. Resistance to fuel spills. Asphalt is more durable. Another major factor that separates the two is resistance to fuel spills. Tarmac is highly susceptible to damage when exposed to diesel or petrol. Since it's made using tar, these petroleum-based fuels can dissolve the tar, weakening the bond between aggregates. Over time, this leads to surface degradation, cracking, soft spots, and even potholes. In contrast, asphalt is far more resistant to fuel spills. Bitumen, the binder used in asphalt, does not break down as easily when exposed to petroleum-based liquids. This makes asphalt a more durable and low-maintenance choice, especially in places where fuel spills are common, such as gas stations, parking lots, highways, and service roads. Because asphalt holds up better against chemical damage, it requires fewer repairs, increasing its overall lifespan and saving maintenance costs over time. Section 10. Maintenance. Asphalt again has the edge. Maintenance is where tarmac really falls behind. Due to its rougher texture and the use of larger aggregates, tarmac is more prone to cracking, surface wear, weather-related damage. To keep it in good shape, tarmac roads need frequent maintenance, including crack sealing, patching potholes, resurfacing. All of this adds to long-term upkeep costs. In contrast, asphalt requires much less maintenance. Its smoother, more uniform surface is better at withstanding temperature changes, heavy traffic, rain, and UV exposure. Asphalt surfaces are also less likely to develop potholes, and when maintenance is needed, it's typically limited to seal coating or minor repairs. This makes asphalt the preferred option for high-traffic areas and long-term use. Asphalt versus tarmac, which one wins? To sum it all up, asphalt is smoother, more durable, flexible, recyclable, and ideal for high-traffic and long-term applications. Tarmac is cheaper and quicker to install, but less durable, non-recyclable, and prone to fuel damage and wear. That's why asphalt has become the leading choice for modern road construction, airports, highways, and urban infrastructure. Asphalt road fading into a sunrise. We hope this video helped you clearly understand the difference between asphalt and tarmac. If you learned something new, don't forget to like, share, and subscribe to our channel Civil Engineering Edge for more exciting content on construction, engineering, and infrastructure. Check out our other videos by clicking on the links right here, and keep exploring with us.